So is this function x squared function onto?
Yes.
Yes. Who was it?
Andrew.
Andrew? Andrew?
Yes.
Okay, maybe there's a delay. Um, actually, it's not. Do you see why?
So that means no.
Oh yeah, great. It means no.
Is
Yeah,
it because if y is negative, there's no x squared?
exactly. So consider -1 in y. Yes. Remember, y is not the range of the function, but codomain. So in this case, what is y? This is your y, and clearly -1 is an element in y, right?
Mhm.
Okay. So this is not the range of f. Okay. But is there a, so -1's here, is there an x value such that f of x is -1?
I
What do you mean I?
like square root of -1.
Huh? I mean, okay, so x squared is -1 means x must be like, oh, you mean like plus minus I, right? But this is not a
Yeah.
real, it's not a real number. So I is not definitely an element in I, right?
Yeah.
Okay, so there is no such x that gets mapped to -1 or any negative number. So this one clearly violates the onto definition. So the answer is what? No. So this is no. Okay. I, I believe we discussed this in class this semester. Maybe not. Did we do this or did we not do this?
I don't think so.
Yeah, I think so. But
Oh
anyway,
yeah,
it's okay.
I think your wife talked about it.
Um, I'm sure. Yeah.
It was with your wife.
Yeah, she was the one who originally taught us the onto or one-to-one.
Oh yeah, yeah, yeah. Of course, yeah. Yeah. All right. So can we move on to the next slide?
Yeah.
So okay, so there'll be a question about 120 Antony's on the next test. Um, and then a basis of a space. All right. Wait a sec. This is there is a typo here. Uh, linear independence. Okay. So suppose you have a set B. And B, the set B has these vectors as elements. And what do we mean by the vectors in B are linearly independent? So, of course, independent simply means linearly. So what was the definition? There was an equation, right? You set that equal to 0.
C1x1 plus
Yeah.
C2x2.
Well, in this case, B1, right? So
Yeah.
C1, B1. Consider this equation. C2, B2, Cn, Vn. This equation has only what?
Trivial solution.
Zero solution. Doesn't mean no solution, zero solution. So
Yeah, trivial.
yeah, okay, so maybe that's better. And the trivial solution, meaning, yeah. I'm sorry. So that means all of this, okay, must be 0. Okay. So we know this. For instance, if I have 1, 2, 2, 3, Um, is this set linearly independent? What do you guys think?
Yes.
You sure?
Yeah.
I'm sorry. Why are you guys chatting about gaming? Yeah. Okay. Don't do that.
So I have a quick question. So
Okay.
it's only the trivial solution because each vector is independent, correct?
That's the definition. So if it turns out that only the trivial solution, meaning this all the c's must be 0, then we say that the given vectors b1, b2 up to bn are linearly independent. That is the
Okay.
definition that you have to memorize.
Yeah. Just double checking.
Hey, is this my boy?
It is.
Oh, hey. Shalom.
Shalom.
Okay. All right. So yeah, this is yes because there's no. Okay. So if you consider C1, 1, 2, C2, 2, 3. If you consider this equation, then only 0 here and 0 there will satisfy this equation. Okay. What about if I have 1, 2, 2, 4?
Yes.
Are these vectors linearly
mean, no.
independent? The answer is no, because I can come with non-zero c's, okay, such that this is still true. Can you come up with what are those constants?
-2, 1.
So -2, 1, okay, or any. It's not unique, by the way, okay. So we could have -4, 2, that kind of stuff, right? All right, so okay, so try to memorize this definition. Okay. Yeah. Instead of gaming all day. Okay.
Hey now, gaming all day is the best.
Well, if you're a
Yeah.
professional gamer, then
I
you're being
might be.
productive.
You don't know me.
No? Okay. Okay, and then a basis. Excuse me. A basis of a space. Let V be a vector space. And what do we mean by B, a basis of V? So two things, right? We need two conditions for set to be a basis of vector space. Anyone? Mm-hmm. Okay, anyone, guys?
So that means that B is linearly independent, and that there are there's one other condition about it covering all of the
Yeah, the span thing, right?
vectors. Yeah, the span. Yeah.
The span of these vectors, B1, B2 up to Bn, becomes V, okay? Yep. Okay. So here's the definition. Yeah, this is from a previous lecture. Okay. So a subspace H, and then you have some set of vectors. This is a basis. We say that this is a basis of H if B is linearly independent and if it spans the whole thing. Okay. All right. So so let's look at this example. We have a set B of two vectors. Is this the basis for R3?
No.
Okay, that was quick. Okay, and why would you say that, Hannah?
Because there's only 2 vectors, we need 3 vectors. So there
this-
wouldn't there would
yeah.
be a free variable if we had another vector there because it'd be a 0.
There is no free variable here. We have two.
Because there's not a pivot in every row. Right?
What? Okay, so I think what you're trying to say is, I mean, eventually what you said is correct. What you're trying to say, what we want to say is following. I mean, these are linearly independent. That's for sure. So 1 is true, but 2 is not true. This condition here. Why? Because if I spin these 2 vectors, 1, 0, 0, 1, 1, 0, yeah, then this does not equal to R3. Okay, you see that?
Is that
Because when-
because the bottom there's nothing in the bottom?
Yeah, exactly.
Third element?
I mean, there is something there.
Yeah, but
Yeah.
not a non-zero number.
Yeah. So for
Okay.
instance, this is definitely an element in R3, but you cannot get this from a linear combination of these two. You see that? Yeah. So meaning this actually spans, um, I mean, this spans R2 with 0 actually, but not R3. Okay. What about this one? Can this be a basis for R3?
Yes,
I mean, no.
that's what I meant. Yeah.
Yeah, of course. Yeah. Yes means no, right? Okay. Why is that? Why is the answer no?
Is it because of the 2, 3, 5 vector?
Or yeah, I mean, yeah, it could be this or that. We don't need 2 of these, right? Just only 1 of them. For instance, yeah. So remember, for a set to be a basis, first and foremost, the set has to be linearly independent. This is not linearly independent. Is that clear? Yeah. Mm-hmm.
Yep.
Okay. Okay. All right. Okay, then let's move on to the unique representation theorem.
Someone asked you a question why the last 4 vectors weren't linear independent.
Because I can write this vector in terms of the 3 vectors. Mm-hmm. Oh yeah, by the way, if you just text me, I mean, I see it, but there's no notification, so I don't know, yeah.
Or
Is
just
this-
unmute the mic.
Should I do this? But it'll be too distracting, so yeah. Okay. All right, then let's move on to the unique representation theorem. The okay, so let okay. So there is excuse me, 2 new messages. Okay. Yeah, okay. All right. So what does this theorem what is it talking about? So you have a vector space, okay? And you have a basis set beta for the vector space. And for each x in V, there's an element in V, there's a unique set of scalars C1, C2 up to Cn such that this is true. It has to be unique. Wow. Do you believe this? Everyone?
Maybe.
Maybe? Good. Yeah, I mean, why should you believe me, right?
1 comma 1 is the only set of numbers to represent 1 comma 1 comma 1.
Oh, I don't think I meant that. Maybe I don't know. Yeah. So let's. Do you want me to prove this to you, or you want to just? I mean, it's not
Prove
really
it.
important, but
Do
what do you guys?
it.
Do it.
Huh?
Prove it.
Prove it. Okay, good.
Yeah.
So existence is really easy. Okay. So remember, for this to be a basis of V, what was the second condition?
Linear independent.
That was the first condition.
Span.
Yeah, the span of. Okay, not if and only if, but okay, this implies that the span of V1, V2 must be V, right? Yes. And what does that mean? For every vector x in V must be able to what? Be written in terms of these vectors. Yeah? Yes?
Yes.
No? Okay, then
Yes.
okay, good. Thank you. That means x should be written as C1, B1, okay, C2, B2, Cn, Bn for some C1, C2, Cn, okay, by definition. So that's the existence, okay? Any questions? So the difficult part, I mean, relatively speaking, is proving the uniqueness. So how can we show that once you find a set of these numbers for this, that's it. That's unique. There's no more other constants that will give you this. How do we prove this? Well, suppose, so we'll prove this by contradiction. Wow. I don't know what I did, but I like that. All right, so suppose there exists, this means there exists, okay? A set D1, D2 up to Dn. So you have different set of scalars besides that, okay? Such that x can be written as D1, B1, D2, B2, dot, 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 Dn, Bn, okay? So we already have this set of constants, so C1, C2 to Cn, and x can be written using those constants C1, C2, those C's. And then suppose we have another set of constants D1 up to Dn, such that x can be written in terms of using these constants. Yeah? Then clearly what must happen? That means x is this, but x is also that. So if I set those two equal to each other, what do we get? C1, V1, C2, B2, Cn, Bn must be equal to D1, V1, D2, B2, dn bn. And if I move all of this to this side, then we get C1 minus D1, B1, D2, D2, B2, Cn minus Dn. Bn must be equal to 0. And there should be, at this point, there should be some light bulbs going on in your head. Is that happening with you? Light bulbs?
Now it's only a trivial solution
Why is that?
because C and D are equal.
No, we don't know that yet. We want that to happen, right? But we don't know that. So we want these to be all 0. But what would guarantee that, if you had to guess?
If they're both the same number, then it would be 0.
Or it
if-
could be
if
1,
C-
1, 2, 2. Yeah, I mean, they don't
Yeah,
have
so
to.
if C1 and D1 are the same number, and then C2
Yeah, yeah.
and D2 the same,
Well, why? But yeah, the question is, why is that true?
because 1 minus 1 equals 0, and 2 minus 2 equals 0, n minus n equals 0.
I mean, what you said is true, but not relevant. Because what were those b vectors? The b vectors come from? The b's came from, it was a basis of the vector space, right? Then what was the first condition of a basis?
Linear independent.
Yeah, the vectors must be linearly independent, okay? And by definition, then, when you see something like this, what must happen? All these coefficients must be
0.
yeah, because
To be linear independent, they have to
yeah,
be 0.
b1, b2, dot dot dot, b and r linearly independent. This is by definition. Okay. Therefore, c1 must be d1 for the coefficients to be 0. d2 must be d2. Cn. Now, what does this tell you? It tells you that this representation here must be unique. If you find a different set of scalars such that this is true, then those scalars must be just the same as C1, C2 up to Cn. Okay. So that proves the uniqueness part. Any questions? Okay. Oh, did someone say something?
No, so that makes sense.
Oh, cool. All right, then let's move on to the next. Finally, a new definition. Yay. New is better. Okay. So, wow, there are a lot of words. Should I read them to you? I don't know. That wouldn't be very efficient, right?
Yes, we paid you to read words.
No, you didn't pay me.
I think we do.
We pay the school who pays you to read the words.
Are you sure?
Pretty sure.
Okay. Thanks, guys. So, are you my boss then?
Yes.
Indirectly, yes.
Wow. Mm-hmm.
The school is just a middleman.
Mm-hmm.
Don't worry about showing up to work on Friday. You can stay home.
Mm-hmm. Okay, so hey bosses, let's so what should we do? What's going on here? There are a lot of words here. What's the keyword? I mean, keywords.
Coordinates and weights.
Yeah, weights are important. I mean, yeah. We were trying to lose them, right? What about coordinates? Okay, maybe this is better to with an example. So, a few definitions. So coordinates of x. So x is a vector in a vector space, and you're given a basis. Okay, it's an A basis, by the way. It's not unique. The coordinates of x relative to the given basis beta, or beta coordinates of x, that's not important, are the weights given by D such that this. Okay. Remember, if you're given a basis, then any element x in V can be written in terms of those basis vectors, right? And these weights here, or coordinates, are the coordinates of x, okay? So the notation that we use is this, which is just that. It's called the coordinate vector of x, okay, relative to this. All right, so here's an example. Suppose consider a vector 1, 6 in R2, and consider the standard basis. So E1 is 1, 0, E2 is 0, 1. Okay. Then let's find the beta coordinates, or coordinates in terms of or relative to beta, and coordinate vector of x. What should we do? Anyone? So I should be able to do something like this using 1, 6. So let's do that. So you have 1, 6 here, and I want the coordinates 1, 0, another coordinates 0, 1. So maybe I can call this C1 and C2. Can you guess C1 and C2 such that this is true? My goodness, music to my ears. Who did that?
I did.
Okay, who's I?
Me, Sebastian.
Sebastian. All right. Why'd you delete that? It was the correct answer.
It won't
Oh,
stay
so
on
you
the
can
name.
write it more better.
Delete right away. Okay, anyway, yeah. So it could be 6, 1 and 6. Yeah. What does that mean? That means the x coordinate in terms of this beta is 1, 6. All right. So in this case, the vector itself is equal to the coordinate vector. Okay. This was too easy. So let's try something slightly less easy. All right. Okay. So most likely this will be the last example for today. Maybe not. We can do one more. Let's do this together, okay, everyone? What do we do? So x is 1, 6. To find the coordinate vector, what we need to do is what? I mean, if you find this, then this is automatic. You can just write it in a vector form, that's it. So I need to do something like this. So given 1, 6, which is my x, I want to find, let's call this B1, B2. C1, B1 plus C2, B2. Okay, so I want to find these ways, or coefficients, C1, C2. So let's write this equation using the actual vector. So C1, 1, 0, C2, 1, 2. Can you solve for C1 and C2?
1, 3.
Oh, you just guessed?
No.
It's negative 2, 3.
So wouldn't it be -2 and 3 to cancel out?
I didn't see the 1 on C2.
Oh, was it Alex?
Yeah.
Alex, buddy, how are you?
Me?
Yeah.
Doing fine.
Did you catch Corona?
Hey, that was nice.
How's everyone with their like toilet paper? You guys should have been stocked up a little bit by now.
Hey,
Stocked up on food, not toilet paper.
Same.
I told you guys this will be like going on for like at least 2 weeks to 2 months, but yet
He's a prophet.
Dog food too.
The Muhammad
okay,
of our
so
era.
all right, so okay, anyway, yeah, we can talk about that later, but yeah, so how do you find -2 and 3? This was easy to I guess it wasn't too bad, too hard to guess. Because it was just two-dimensional vectors. But what if it had three vectors, 4, 5 vectors? Then what? What do we do? What do we do? Well, this is nothing more than what? 1, 0, 1, 2, 1, 6. This is the okay. All right. Okay, let me take over. Okay. So 1, 0, 1, 2. Yeah. Okay. Okay. Then the solution to this system will be what? Exactly C1 and C2. Correct?
Right.
And all right. Then do you miss doing this? We haven't done this in a while. So I want this to be 1. So R2.
divided by 2 equals R2.
Alex. 0, 1, 3. And I want to get rid of that. So what?
R1 minus R2 equals R1.
Okay. 1, 0, and then -2, right? Okay. That means C1 is -2, C2 is 3. All right, you're done. Okay. So that means X beta, in this case, is -2, 3. Right? Yes?
Yes.
So notice that this is different from this one. Because this was relative to a different basis, right? And obviously, when you have a different basis, coordinate vectors will be different. Okay. I think we have time for one more, maybe. So the basis this vector is that this is a vector in R2. Okay, then what is that? How do you find the coefficient? So basically, again, what that means is I want to be able to write 4, 5 as C1, 2, 1, C2, -1, 1, right? Correct? This is what I want. And I want those C1 and C2, which will satisfy that. So again, all you have to do is what? Consider this augmented
C1
matrix.
is 3, C2 is 2.
Oh, did I make a mistake?
No, I'm saying what C1 and C2 is.
How did you do so quick?
I
found
tried
two
to
of
get
them.
C2 and tried to find out from there. And the best way to do it is have by 2. And then if you have C3, C1 and have by 2, then you would have 4, and you have 4 there.
I see. Okay,
four-
so yeah, but unfortunately on a test you'll have to show work such as this, okay? Alex?
I got you.
Yeah, I mean, because you know, you can't just say, "Oh, it was obvious to," you know, you can't say that unless you're like Einstein or something. Okay. So what can we do? Maybe I can flip these two. Was that the best way to do it?
I would flip the top and the bottom.
Yeah, okay, so let's do the R1 and R2. 1, 1, 5, 2, -1. No, no, no. 4. And then get rid of this. How can we do that?
-2 times R1 plus R2 equals R2.
Okay. 1, 1, 5, 0, -3. So -10 plus 4, -6. Is that right?
Yes.
Okay. And I can divide this by 3 and get what?
Divided by -3.
Okay, well, it's same thing, but
No, it's not.
okay, you win. This is 5. And then get rid of that, right? So 1, 0, 3, 0, 1, 2. Is that correct?
Yes.
So do something here. Yeah. Do something here. Okay. That means what? C1 more 3. This is 2. Alex, was this your answer?
Yes.
All right. Now I trust you. Anyway, but you have to show something like this on a test, okay? Oh, actually, I never mind, because it's gonna be an online test, right?
Yeah.
Yes.
Oh yeah. I don't know. Yeah.
Is it all multiple choice?
Maybe multiple choice, multiple select, short answer, you know, that kind of stuff.
My favorite.
Yeah, I didn't know you had any favorites. Let's check. 3 times 2 is 6. -2, is that 4? Yeah. 3 times 1, which is 3. 3 times, yeah, so this plus this will give you that, right? Okay, so we did this using this is what I call brute force way. So given a basis, given a vector, we find the coefficients using this using elementary operations. Next time, so it'll be Friday. We'll use some more faster, sophisticated way of finding those coefficients. Okay. Everyone, are you guys
Sounds great.
okay?
Sounds good.
Sounds good.
Please, we're going to try a mock quiz. Okay. Again, it will be extra credit. I'll give you some really simple
Yay.
questions. Yay. And then but it'll be done using it'll be done via the lockdown browser. So basically just to test whether you guys can your computer can do that. Okay. Make sure that you have a webcam by next time. It'll be done real time. Okay.
So next time is Friday?
Yeah.
Are we having tests on Friday?
No, we have a mock quiz. A mock. Yeah.
So
yeah,
it
to
won't let
test
me in
the
at all if I don't have a webcam?
Extra credit quiz.
Oh, are you getting one from Amazon?
Yeah, I mean, I can try and get it by Friday.
Yeah. Okay.
Don't hold your breath on that because Amazon shipping has been taking long on everything.
Yeah.
Stuff that's supposed to
I was
arrive
feeling
on Monday for
because
me
right
is
now
gonna arrive
everyone's
like next
shopping
week.
online, so unless it's food, I guess, right?
Yeah, Walmart's still open if you need to go to Walmart, and Best Buy probably is still open, but I don't know how cheap those are.
Target's open too.
So I'm
Micro
gonna,
Center is good too.
so everyone can just hear this. The thing is, expect nationwide quarantine coming up soon because we're already at like 9 states all in lockdown right now.
Is Georgia in lockdown?
No,
Good.
not yet.
Not yet.
We'll all die together. It's fine.
If I die, can you just give me an A in the class?
I'll give you an
Isn't
A.
that like a rule? If
Me
someone
too.
dies, that we get
Yeah.
A's.
That was an old AP exam.
Let's
Rumor.
take
I
him
don't know
for
if
the
it was.
team.
I don't
Who's
know if it was
taking
rumor.
one for the team?
Hey, you know what? I'll do one better. I'll
Why?
give an A plus,
Oh,
Thank
sweet.
you.
Oh,
He's a
thank you
man.
so much.
and I'll attend your funeral too.
Well, attend your
It's
people
okay.
Skype.
Can you speak at my funeral?
Sure.
What is he gonna say?
Shalom.
But
Good
you're
luck,
not gonna
good
know,
luck,
so
good luck.
I can promise anything right now. Anyway, yeah, don't die, okay? So any
Any
questions
like
about today's
them.
lecture?
No.
No,
Nope.
Good lecture.
it
Not a
wasn't
10.
it wasn't too bad, right?
No.
Yeah, this one was pretty
So-
It was
alright.
good.
Yeah, so tomorrow it's gonna get more not tomorrow. Next time it'll be more yeah, it's not going to be maybe it won't be too easy, okay? So all right guys, then I'll see you all next time and have a webcam ready, okay?
Alrighty.
All right.
All right.
See ya.
Bye.
See ya.
Stay safe.
Yeah.
Hey, Kang. I'm just
Yeah.
gonna stay here for a little while if you want me to.
Adios. How do you
Bye.
So, what do you want to talk about?